Hi, and welcome to another session of the Microsoft Virtual Academy. In this session, we're going to take a look at some software development fundamentals. This will actually focus on some preparation for our MTA, Microsoft Technology Associate Certification Exam 98-361, and we'll cover some core fundamentals that you'll need to understand as you get started in software programming. So let's go ahead and introduce who your presenters are today. My name is Gerry OBrien, and I'm a Technical Content Development Manager here at Microsoft. I've been focusing on the developer and the SQL Server platforms for some time. I'm also a content author. In a little over 18 years of experience, 8.5 of that here at Microsoft, and I'm a Microsoft certified trainer, been a software developer and a consultant in the industry, written numerous books on IT topics, and actually written a few courses as well. Currently program in Visual Basic, C#, Java, and Objective-C. And the most important part I like to have at the last is I'm a lifelong learner. So like you, I enjoy learning about technology. That's kind of where I'm at today. I continuously learn on a daily basis. So now I'll let Paul introduce himself.
Hi, my name is Paul Party, and I'm a content development lead at Microsoft. I've been in the software industry for about 20 years and doing programming most of that time. And I started out programming in Visual Basic and moved to scripting, and then I moved into object-oriented languages like C# and spent most of my time in that language. I've also programmed against SQL Server, so that gives me some experience with databases as well. I co-authored a book on Microsoft Access many years ago, and recently published an app to the Windows 8 App Store called Movie Notes, which I'm very proud of.
Great, thanks Paul, and welcome. Glad to have you here on my team as we present this MVA. So a quick overview of what we'll cover today. In our software development fundamentals, we've got about 7 modules to go through, so over the next few hours we'll take a look at some general software development. This is where we'll focus on some of the non-coding aspects of what a software developer might have to do on a day-to-day basis. We'll take a look at the application lifecycle management and a little bit of a discussion on how you might evaluate technical specifications. Then we'll start getting into kind of the meat of what we're going to do in Module 2, which is core programming, and this will focus a lot on how a computer stores and processes information, what you expect to see in terms of working with some of the different aspects of programming like decision structures and repetition, and how programming errors creep into your code and how you can work with those successfully and, to basically get your program up and running again. Module 3 takes a look at object-oriented programming, and the thing that's kind of interesting about the way software development has changed over the years, folks now start looking more at trying to model real-world objects in the code that they're writing, and object-oriented programming gives us that ability to do that. So we'll take a look at how we can model those real-world objects, how object-oriented programming plays a very important part in what you'll do as a software developer. Then the next couple of modules, 4, 5, and 6, will give you the opportunity to take a look at examples of some of the types of applications you might be developing. So we'll focus on web applications, take a look at what core, just basic HTML pages look like, and then take a look at what a web application is, how it's hosted on the different platforms. Then we'll give you an example of some of the different desktop applications that you might be focusing on. So even though the web has become relevant over the years, folks spend a lot of time on the internet now, there are still applications written for laptops and desktop computers, so it's important that you understand what those are and what you might be involved in developing from that perspective. Also in Module 6 we'll take a look at databases, because I would say about 99% of your applications today focus on data, and you have to access that data somewhere. Most of the time it's in a database, so we'll talk about databases. We'll give you a demo of SQL Server, show you how you can extract some data, insert and update information in a database, talk briefly about how programmers will connect to it, and then finally we'll finish off with a quick little discussion on, after you've basically seen everything in this session, is this for me? Do I want to pursue software development as a career? Is this something that interests me? And it doesn't always have to be a career. Maybe you're just looking at it from a hobby perspective, and that's perfectly fine as well. But we'll present some resources for you at the end, show you some links to some training, certifications, and how you can ramp up on some more core fundamentals. Obviously, we want to do a little bit of expectation setting up front. We want to let you know what we expect you to have in terms of a mindset and maybe a skill set before you step through this. Software development is not always an easy process. Some of the concepts that you'll learn, or as you go through learning new programming languages, may be a little different than what you're used to, so there's some things that you might want to be aware of. We've listed 2 bullet points here for target audience. And first of all, it's a desire to get started in software development. Otherwise, you wouldn't be here. So that's kind of important, you know, that this is what you want to do, or maybe it's something you think you want to do. So you should have that in mind. You should also be a little bit technically savvy. And this is kind of an ambiguous bullet point. What does technically savvy mean? Does that mean I need to have an engineering degree? Do I need to understand at the deepest level how a computer functions internally? No, that's not what we're saying. But you should be able to understand technology. You should be able to know how to turn on a computer, execute programs, you know, start them up and find your way around file systems and things like that. That's kind of what we're talking about. We do list some suggested prerequisites, and the first one is kind of logical thinkers. That's a little bit of an interesting bullet point as well, because what is a person who thinks logically? And as Paul and I were discussing this the other day, I kind of brought up a little bit of a scenario for him in thinking about, most people have a typical morning routine. So you get up in the morning, you know, the alarm clock goes off, you turn it off, hop in the shower, you get dressed, you get out and you have breakfast perhaps, you hop on a bus or in your car and you head off to work. And for most people, that's it. We're happy with that, and that's all we need to worry about. But as a software developer or a computer programmer, you need to dig a little deeper into the concepts of that. So logically thinking, you're going to have to start breaking that down into discrete steps. The alarm clock goes off in the morning. Well, there's a decision to be made. Obviously, you're going to turn it off because it's annoying, but the decision is, do I pay attention to it and get out of bed and go to work, or do I play hooky today and I'm just going to stay off, you know, and stay home sick and not go to work today? So, you know, you start getting deeper into these decisions. When I'm going to take a shower is my next step. Well, there's some logical thinking from that. Is the shower available? If it's not, what am I going to do next? That's the kind of thing that we're referring to when we say logical thinking. You have to start breaking things that you take for granted down into discrete steps and thinking about them from a different perspective. It would be nice if you do have some experience with scripting or beginner programming tasks, although it's not technically necessary here, because we're going to be showing you some code for the samples, and the code that we're going to show you may be foreign to you if you've never seen a programming language before. So if you've got a little bit of that experience, then some of the concepts might be a little bit easier to see from that coding perspective. The ability to understand patterns. Programming deals a lot with patterns in the code itself. We'll talk about how repetition structures create patterns as we repeat and iterate through different loops. We can also talk about how patterns are present in things such as numbering systems and the different sets and the different aspects of the code that you'll deal with. It'll become more apparent when we start focusing on things like our data structures. When we look at arrays and queues and lists and stacks and things like that, you'll need to have the ability to see how patterns are present in these things and work with them specifically. And then finally, a grasp of mathematical concepts. Now, you don't have to be a mathematician. You don't need to have gone through university and gotten a degree in mathematics, certainly. But understanding some of the general concepts, such as what is a set. In programming, we deal a lot with sets, which are specific values of numbers, text, characters, what have you. And you should also understand numbering systems, because when we start dealing with the data types that a computer stores and how it stores them through the binary concepts, you'll need to understand the different numbering systems that we have and how you work with those specifically in the programming language you're choosing. Because a computer can't store infinite amounts of information, our number systems in computers are limited to certain values. So an understanding of that really helps as you start working through your programming career. Now, obviously, you're here on the Microsoft Virtual Academy. If you haven't already joined the MVA community, you should sign up. You should register for this. It's a great opportunity to get some free online training targeted at developers and IT professionals. We've got over 1 million registered users on the system already. It's a very popular platform. We've got some great training on here. Take a look at it. We're always updating the content on here so that we become relevant to what it is that you're looking for. If you see something that's not on there, hey, use the contact information on the website and suggest some topics. We're more than happy to add them. So again, welcome to the MVA community. And let's go ahead and take a look at our first module. So we're going to focus on general software development here. And again, as I mentioned from the intro, general software development will focus on a couple of key aspects that are not specifically related directly to coding. So you're not going to be writing code, or we're not going to be presenting code in this one, but it's more around the processes that you can expect to encounter as you start working as a software developer. These can be as an individual developer, or they can be as you're working in a larger shop, such as here at Microsoft as a software developer as well. So we'll take a look at the application lifecycle management, and we'll also take a look at how to interpret application specifications. So first of all, in application lifecycle management, again, this is something that is not specific to coding, but it is a process that we use in the industry to help us understand how software is created and how we go through the implementation, designing, testing it, deploying, and managing it. So what you typically find in the industry is a diagram that looks similar to this. Now we have 5 discrete boxes on here: requirements, design, development, test, and maintain. And this is what you'll typically find listed as an application lifecycle management. Some people call it a software development lifecycle. We could even call this a product lifecycle management. It's not specific to software development, because what it does is it focuses on, again, it's a process. It's a key process that helps us get to where we need to be from our software development lifecycle. We take a look at the box on the top is requirements, and typically this is considered to be the first step in this whole iterative process. Realistically, there's actually one box that we don't see here that we could have added, which is one called envision. So typically before we decide we're going to create a new product or a new software application, somebody has to have a need for it. And this might be a business, a company, it might even be yourself. If you're going to be somebody who writes your Windows Phone applications or iPad applications, you're the one who's going to envision that product. This is, I want to create a software application that does X. That's envisioning. That's essentially what it is. Once you've come up with that vision, you've come up with that idea that you say, I want to create this application to do X, you've then got to sit down and figure out what the requirements for that application are. And what we mean by requirements is there are specific feature sets. We want this application to perform something. We want it to do something. We want an end result from it. And as a result, you'll come up with the requirements that say, this is how I want the application to work. This is what I want it to do. The requirements typically end up being a requirements document. If you're developing this for somebody else, you'll typically sit with somebody that we call a product owner. And that product owner could be the company you're developing the application for. They'll give you the specific requirements that they're looking for, what they want the application to do, and the business problems that they're trying to solve. And then you will document those in the requirements document itself. Once that's completed, you might be the person who's creating the design in the next step. The design could be done through use of a software architect, who is typically somebody who understands the software development process really well, but also understands the technologies that you'll build into this, and they will create a software design talking about the different technologies they'll use to create an application that solves the requirements and the business problem for the user. There are different terms used for the software architect. Microsoft also uses a term called a program manager. They'll typically sit down, read through the requirements, and create something known as a functional specification. We'll see that in the next slide when we talk about the application spec, a couple of different names for it. But essentially, we're creating a design for the application that might say, how does the application function, and how are we going to create it on the specific platform that we're using. Another key aspect of this when we talk about the design is we might end up dealing with things called storyboards, which basically kind of dictate the flow through the application, how users will work with the application and the different components that make up the application itself. And those will also consist typically of mock-ups, where somebody will take a design program. Oftentimes it could even be the back of a napkin. Somebody's just drawing a picture with a pen and paper and saying this is what we think the user interface will look like. That's all a part of the design process. Once that's completed, we'll then pass that off to the software developers, the people who are actually going to write the code. They may or may not take that design document and then go through writing something called a technical specification. Again, this is another document that they go through the process of creating in their favorite word processor or some other application where they want to store the document. And what it does is it creates for them a way of dictating how they're going to actually create that functionality in code. So the functional spec doesn't get into how we implement it. It just simply says how we want the program to work. The technical specification that a developer might create will say how they're going to do it, what technologies they're going to use, what types of data structures they'll implement in there, whether they're going to access data locally, whether it's going to be on a back-end server. All of these different aspects typically form the technical specification. And once that's done, the coders can actually start writing the code itself. So they can start doing the development of the application. Now, the next phase talks about test. And one of the things that's interesting about test is we can kind of break it up into two different aspects. There's testing during the development process itself. And what this involves is something called unit testing. Most of the times your developers will create something called a unit test, which is code that they write that tests little pieces, of discrete pieces of functionality that they're writing. So they can run tests before the code is even completely finished. Then we also have in the development process a whole test team, and their responsibility is to look at the functional specification, know and understand what the program is supposed to do, and then write automated test routines that go in to check to make sure the code executes what it's supposed to do. So if we have a, let's say, a looping structure within our code that's designed to iterate through a collection of items and output a specific value, they'll write an automated routine that checks to make sure that that looping structure does what it's supposed to do. We also have other aspects known as user acceptance testing or business acceptance testing. So we refer to those as UAT and BAT. Some people call it BAT, but it depends on your pronunciation of it. But what that is the code is almost at a state where we're ready to release it, and then we'll let the users play with it. We'll let the business take a look at it and make sure that it meets the requirements that they laid out. And we'll test it to make sure that it works in the user's hands. And one of the things that I used to tell the students that I taught in computer programming was, you could create the greatest application in the world and think you have absolutely no bugs in your code, and you've tested it and it works, but that's because you know how it functions. And you give it to the user, and probably within about 5 minutes, they're going to do something you didn't expect them to do, and they've just broke your application. So user acceptance testing is very important. To give you a better idea of where you might find that is, consider beta tests. So beta software that gets released, and Microsoft does this all the time. We release beta versions of the products for people to test and kind of bang on, and we collect feedback over issues that they run into, bugs that might pop up in the code itself, and we fix them before we do the final release of the product. Our next phase talks about maintaining the application once it's actually available. Again, there's an extra little box that kind of sits between the test and the maintain that we don't have here. And sometimes it's put in there, sometimes it's not, because it's kind of implicit. Before we maintain the software, we have to deploy it. So this means we're getting it out to the customer. They now have it in their hands. We've deployed it to their systems. It's running on the computers, and they're ready to start using it on a day-to-day basis. Now, the maintenance phase means that we could have in our application instrumentation, which means that as the application runs, we record specific pieces of information about how it operates. Maybe it's for performance checking. It could be if there are other bugs or errors that pop up that we didn't discover in the testing phase. We write them out to a log so that later on we can look at it and see what those issues were. It's important for that maintenance phase because software applications don't just get written and deployed and forgotten about while users go through the process of using them in their day-to-day lives. We typically maintain that, and what we mean by maintaining it is we're fixing bugs or we're coming out with the next major release. Over the past few years, one of the biggest things that we've had to focus on, not just here at Microsoft, but all companies doing software development, is security of the software itself. And we release patches on a regular basis. If you're not familiar with something called Patch Tuesday, that's probably the reason why your computer reboots on a Wednesday morning or late Tuesday night if you leave it running, because we're sending out patches to software as we discover issues and problems with the Microsoft software that you use. That's a part of maintaining. It might also be that we're creating new versions of the product. So again, if you take a look at the Microsoft Windows operating system, how many versions have we gone through over the years from that? That's an example of maintaining the software that we've deployed. So again, this is your application lifecycle management. Not really involved with coding, but it specifically talks about a process that you can expect to be involved in as a software developer.
Gerry, before you move on, you said something before interesting that this process applies to many different industries. So you might see this model in the automotive industry or anybody who makes a widget or a piece of hardware. What might be a little bit different about software is that software developers might go through this cycle multiple times in a week or a month. You're working through requirements, you're working through design for new features that you're building. So even though in that maintaining phase you're fixing bugs, you might actually go through this entire cycle multiple times as you're developing new features, which I think is a little bit bit different than other industries when we think about how software is developed.
Yeah, and that's a good important point, Paul. So, thanks for bringing it up, because one of the things I did forget to mention was, if you look at this diagram that we have for the application lifecycle management, you'll see the little arrows between the boxes, and it kind of cycles. So that lets you know that this is an iterative process. We can be doing this continuously over and over again. And as Paul mentioned, for different industries outside of software development, they may do this whole process for creating a part for a car.
Correct.
And they'll design and create the part itself, and then they'll test it and it doesn't work. Well, we got to go through this whole process again. So yeah, great interjection. Thanks, Paul. All right. So next, we'll take a quick look at an application specification. Now, sometimes these are called functional specifications. Sometimes there are different names for them. But again, this is a part of a process. This is a part of the software development lifecycle process we just explained. And you'll find these come in different forms. And the example that I'll give you here is just one that I was actually involved in. I wrote this one up for an internal application that I was working on, not as a developer, but as a program manager here a little while ago, probably about a year or two back. And to give you an example of what it might look at, I'm showing you here, I have Section 4, Section 5, there's obviously 3 sections ahead of it. So you'll end up with things in it that are like an executive summary of what this is, why we're doing this, and then there will be something that says the current state, what's the issue, what's the problems we're trying to solve, and then there might be another section that says how we're going to get to solving this problem. But the key parts of what the developer will focus on are, these 2 sections that we're looking at here. So there's a feature list, and then there's a feature overview. And if you look at the feature list, you see we've got some high-level bullet points here, and then we kind of drill down a little bit deeper into some of the other bullet points. And to give you a kind of an idea of what the application spec is all about, looking at item number 6, we're talking about price checking. This is a specific discrete functionality that we need this process to look at. And so we need to validate pricing. We see as a part of that, there are 3 different aspects. We need to get the product pricing from a spreadsheet. Now, in this case, it was from a spreadsheet, but it could be from any other data source. We want to take a look at all of the courses that we published on that system and pull the pricing back from that. And then we need to do a price comparison. And it's just a validation routine to make sure that what we have set in our pricing back end is reflected on the pricing front end. So also notice that there's no specific implementation details of how we're going to do this. This is just saying this is a functionality. This is what we need the program to do. We get a little more in-depth, if you will, in the feature overview, and what we talk about here is kind of a story about how these features are intended to work. So the bullet points are very high level. Developers can come back and focus on those as a reference point, but the feature overview really talks more about the problems we're trying to solve and how we want to get there. So again, you might find different versions of functional specs or application specs out there. Remaining sections that you don't see in this document are other things that we would create, such as user stories. There's all kinds of object-oriented programming designs that we can add in here. We can use tools such as Microsoft Visio to create use case diagrams where we show little actors and how they interact with the different components of the system and different things like that. So this is not anywhere near a complete application specification. They could be typically 20, 30 or more pages worth of documentation depending on the complexity of the project itself. Again, it's just designed to give you an idea of what you can expect to be reading for you to translate what the application is intending to do and how you would take a look at those from the perspective of a developer ready to write code for it. So.
Yeah, and documents like these are typically created in the first 2 phases of that cycle, that life cycle that Gerry talked about earlier. I also think it's important in the design phase to think in terms of 2 different aspects of a program. So you're going to write a program where there's parts of that program that the user will never see. It's just functionality. The program will do certain things. But then there's also the parts that the users interact with, and that was the aspect of the storyboard that Gerry had talked about. But every program will have something that the user interacts with, and then something that the user will never see. And I think in that design phase, you figure out what those parts are, and the specification will call out the user interface and then the functionality behind the user interface.
Yeah, exactly. Yeah, and that's a great way of looking at it as well. So again, there are different aspects to the software development process, and it's not always as simple as you're just sitting there writing code and expect the application to work. So a lot of the times there's bits and pieces that come ahead of that, right? So just to recap, In Module 1, we took a look at the application specification and the application lifecycle management and how those form a part of what a developer will experience in their day-to-day work as they're creating software applications. So Paul, we finished Module 1, and we hope that you'll come back and join us for Module 2, which will be coming up next, where we'll focus on some of the core programming concepts, again, kind of laying the foundation for what you'll need to know to start on your software development career.
Looking forward to it.